Okay, so last time we talked about the mean value theorem and Rolle's theorem. Today, what we're going to do is finish off the using Rolle's theorem and then the mean value theorem, and then one of these key kind of concepts, which is this idea that we're going to use heavily in Module 4, that two functions with the same derivative must differ by exactly a constant, the same constant the whole time. So that's kind of the overarching thing. So I think that's probably everybody that's finished their last minute uploads of the quiz. So we will start with the quiz. Okay, so today was the first time that you had to use Proctorio. How do we feel about how that went? Not how much you liked it, because I hate it too, but how do we feel about making it work? How do we feel about getting Proctorio to work? 1 to 5. Um, okay. Proctorio seems to be somewhat anxiety inducing, so let's go over it real fast. The way that's going to work, the way that we're going to use Proctorio for the rest of the class. And the way it's going to work is that so Proctorio, there's questions about Proctorio. So the idea is that Proctorio can see your workspace. So the idea is that Proctorio can see your desk and the mess on your desk, and it can see your page sort of while you're writing. And you might want to like move your your camera, or you might want to invest in uh, I had a Boxer one. You might want to invest in one of these mounts for your camera of some sort. And the reason why I say that is because so it's not staring like down at you like this, but is has a view of you. You can stick the camera in front of your computer a little bit, your computer monitor instead of it being on top of your computer monitor. But yes, it should be able to see the entire workspace. Now, the of course, this is, we're doing it 5 times before the test. The idea is that we should be stressed out about the content of the test, not stressed out about this thing called Proctoria. So what we're going to do is we're going to play with it and play with it and play with it and get it working. A couple little notes though about Proctorio. Proctorio cannot. Also, if you have any suggestions about the process, please by all means send me an email, Twitch direct message, or put it in the suggestions on the Twitch. Because I want to make it so that you're not stressed about using Proctorio. Also, Proctorio does not flag you for cheating. Proctorio flags you for review. The only person that can accuse you of cheating is a TA or me. The TAs are going to review all of the flags. And we know that there's every time that you pick up your cell phone to do the little camera thing, Proctorio flags you, which is why there were separate questions, right? There's a question for I'm doing the thing, and then there's a question for flagging. Is that how do we feel about that? The fact that Proctorio cannot accuse you of cheating, the only thing that Proctorio can do is flag you. So this is this idea that Proctorio can't accuse you of cheating. I can do that. A TA can do that. And really, one of the advantages of the system is that if there's any advantage to the system, which of course stinks, one of the things about the system is that if it does flag you, then a TA reviews all the flags. And if they see something suspicious, they can, elevate it to me because we're both seeing the same record. So, there's going to be a little friction, especially at the beginning. But relax about Proctorio. We're going to want to get it to work. We're going to give you feedback, individual. I'm going to have TAs. I'm going to have TAs look at all the Proctorios from this one and from Wednesday. And we're going to try to give you feedback on how to make it, how to make the system happy. And I know that there are people, it's hard to do this at work. People's brothers and sisters are going to wake up and start playing loud music. If it's good loud music, we're fine with it. If it's lousy loud music, well, you're just listening to lousy loud music, and that's, horrible. So, there's going to be some friction. But we want it to be as useful as possible so that the the test can have um, some integrity. Any other questions about that? Okay. Um, all right. So that's Factorio. So the first question was to make that work. Some people got it, some people don't. We'll talk about it some more. And again, there will be personalized feedback for that. Okay, so state roles theorem. Let f be a function defined on the closed interval, or some d where a and b are interval d where a and b are both in the interval. I'm not sure exactly what I said last time. I should be. I can look it up. But and then let f, f must be continuous on the closed and differentiable on the open. Okay? And if those two things are true, f is continuous on the closed and differentiable on the open, that means that and the endpoints are equal to each other. The y values associated with the endpoints are equal to each other. Then there has to be some x value, call it u, in AB so that f prime of u equals 0. So how do we feel about that, 1 to 5? Well, let's see. Actually went ahead in advance and copied the 1 to 5s in here for the polls. And of course, I don't have everything as structured and ready to go as I should be. Okay, so we feel pretty good about the statement and what the statement means, which is awesome. Hopefully, Peer Leader helped with that. Okay, so, and of course, the picture that you want to keep in mind is something like, let's see, can I make this work today? Something like this. Here's A, here's B, and then there's some point here in the middle where you, oops, nope. Yeah. And there's some point in the middle where u is right there, where f prime of u equals 0. Oh, deleted my. Okay. No. Okay. So for some reason, people are saying that in the notes we had mean value theorem required f of a equals f of b. That's actually not true. I'm saying that that's not the thing's not true. So let me check my notes here. That's here we go. No. Okay, so for the mean value theorem, no, you don't need those things to be equal to each other. And that's the point of the mean value theorem. I just wanted to check the notes to make sure they actually said the right thing. So on the mean value theorem, okay, oops, I want quizzes, don't I? Okay. So on the mean value theorem, I don't require the two things to be equal. And I can say this thing, I could call this thing M, by the way. MAB is the slope of the CCAT line. That was in pre-calc. I actually checked the pre-calc book, which I then left at the office. I went to the office specifically to get a whole bunch of books, including the pre-calc book. I checked the pre-calc book to make sure some things were in there, and then I left the pre-calc book on my desk. And I also left a bunch of my shirts on the desk. Which begs the question, of course, I'm wondering how many people are going to business meetings in nice shirts and pajama pants this week, but it's another thing. Anyway, the thing, you don't know what I'm wearing for pants. I could be wearing my Star Wars pajama pants. So anyway, um, yeah. So, but I have to go get my shirts and the other book from USF. I'll try and keep people 6 feet away from me. Anyway, so how do we feel about the statement for the mean value theorem? 1 to 5. So the picture associated with this would be something like, here's A, here's B, here's a continuous F. You can't really see that, can you? Okay. Here's the continuous F. Um, and then, let's see, there's some way to make a ruler appear. There it is. And then I have this secant line here. And then there's some spot here. Where this is y equals MAB x minus 0. So this would be y equals MAB x minus a plus f of a. And this right here, y prime, so f prime c equals m a b. Yes, so this is the theorem where the slope of the secant line equals the tangent line. And as usual, the top is unnecessary. This is, preamble. I try to make a distinction between the things that are really important and just the preamble. If f is continuous over AB, that means it's defined over AB. So I could have just said let f be a function, but everyone knows that f is a function. That's a convention. So you didn't need that at all. You also don't need this thing, and I think I did that right, but yell at me if I didn't. But that would be the equation for the secant line, and then this would be the slope of this is the place where I have the secant of the slab of slide. So the flipped. Okay, so let's talk about the flipped. I did put it in the other way in the notes. It doesn't matter as long as they match, okay? As long as the f of b is over the b and f of a is over the a. Because all I'm doing, if I do it the other way, all I'm doing is multiplying through by -1 over -1, which is just 1, okay? So the order of this term does not actually matter. As long as they match. As long as B is over B and A is over A, you're fine. So the as long as they match, the statement is equivalent. So it doesn't actually matter. Okay. So we had some good feeling about that. Let's talk about this graph. This graph is actually one of the hardest ones we're going to see in the entire class. It's way harder than the one in the test, if that's what you're worried about. This graph here is the attempt for this, the reason for this problem is to kind of nail home the idea of what's going on here with these two theorems. Okay, so I've got this whole bunch of conditions. First, the condition I've got is that f has to be continuous everywhere. And then it's got to have two roots. But notice here, it's got to have two roots. It's got to be decreasing here but I can never have something that's 0. So that looks like it's going to violate the Rolle's theorem, right? Because I've got two things on the side. But notice I didn't demand here that f prime be defined. I only said that it could never be 0. So I've met one of the conditions for Rolle's theorem. I've actually met two of the conditions for Rolle's theorem. All right? But I've met this one and this one, but I haven't met this one. Okay? So I need to meet, I can get away with this. I can meet these conditions on the left side by, let's see, did I have a condition for the infinity? By doing something like this. And these numbers, or this line is horribly, wiggly. Let me see if I can do this. I figured out how to do this since I made the wiggliness happen here. So let's see if I can do this better. So, something like this will work. Oh, it's not even on 4. Ugh. Oops. So something like this will make it happen. Okay. So yes, and a root is just somewhere where it crosses the x-axis. That a root is a place where f prime of excuse me, is that on the page or on my monitor as an artifact? Oh, it's on my monitor. Okay. So the the root is somewhere where I cross the x-axis, where f of x equals 0, not f prime of x, f of x. So that's how I deal with that first condition. Now, the second one, however, is trickier. One of these cannot be met. Okay, and I made a little note, can be kinky. Now, of these others twos, f prime of f of 4 has to equal 3. But if I do that, I can't make it, right? Because here, the slope of the secant line, which is the minimal slope that I could possibly make, is greater than, has to be greater than 1/2, right? It has to be 3/4. Okay? So so while the left side doesn't violate Rolle's theorem, the right side is going to violate the MVT. So this condition right here cannot be met. So I have to circle it and I have to explain why. So if you say the fourth condition can't be met, that's like 1 point off, because technically I haven't demanded that the thing not be kinky. Okay? Here I have, because here I've said that when I say f prime of x is less than 1/2, I've actually said that the MVT, that the derivative is defined. Here, if I say it's not equal to 0, I haven't said if it's defined. I should have said f prime of x is not equal to 0 or is not defined. Maybe. But the important thing was that here it had to be defined. So as I said, it's like 1 point. If this problem is, there's going to be another one that's hard like this on the bootleg. But this is not the hardest graph. One of the integral condition graphs that's in Module 4 is pretty hard. But this is really the hardest for test 3 that they're ever going to get. Okay, this one is meant to drive home this idea. Okay. Are there any other questions about that? Now, there's a question about it not violating Rolle's theorem because it doesn't even meet the theorem. It doesn't violate Rolle's theorem because Rolle's theorem only talks about when f of a equals f of b is differentiable in the middle and continuous over the whole interval. Okay? So as long as f prime of x doesn't exist, I haven't violated Rolle's theorem because I'm not talking about what Rolle's theorem talks about. Royle's theorem talks specifically about orange juice mixed with mango and strawberry. And if all I have is orange juice mixed with mango, I'm not talking about the thing that Royle's theorem talks about. Royle's theorem talks about something extremely specific, and this thing that we're talking about doesn't meet Royle's theorem. So you haven't violated Royle's theorem because you're not talking about the thing that Royle's theorem wants to talk about. So this is a very tricky one. Kudos if you got it. And again, the parts, if you got lots of it, that's very good too. So again, this problem is meant to drive home this idea about these two theorems. How do we feel about this problem, 1 to 5? Okay. All right. I got a mix. I've got a lot of 3s. I mean, you can actually see what it is, which is nice. Okay. So again, this is a very hard one. The one on the test is not quite, and 2 on the test, because there are actually 2 of these on the test, not quite this hard. Any other questions? Okay, so you all are worried about the test, which is next Saturday. And then after next Saturday, with another 3 weeks of class. So I'll talk real quickly about the test. What we've decided to do is we've it's got more what they call problems. It's got like 12 problems instead of the usual 9. But we cut parts of each problem. So instead of having a problem that stretches over 3 pages, there's 3 pages on a page. There's 3 problems on a page. So the test is not. Don't be intimidated by it. I mean, be a little intimidated by this test. It is harder, but it's not as bad as it looks at first glance. You're going to get an answer sheet, and you'll see what I mean. So the procedure for that is what we're going to do is we're going to give you the answer sheet with no questions in it, kind of like what I do when I tell you what the points are out of everything, usually for the test reviews. I'm going to give you a large answer sheet and a week in advance. So, and you don't have to print it, but that gives you a week to see if you can get a hold of a printer. If you can ask your mother who works at the hospital to run it off for you, or, you can, ask dad to go by the office, or, brother, or, I don't know if any of the campus buildings are open, but if you're, or if you've got a printer in your apartment complex, you can ask the people at the front desk to put it up for you. But again, you don't have to print it up, but the idea is to give you plenty of time to do it. Now, so you can't use tablets for the test. You can't really use them for the quizzes either. We want you to not, and for the bootleg, we want you to not do that. We really want you to, because tablets, I mean, if I can always see the tablet page, it's probably okay in Proctorio. But do we really want to deal with that? And we're having a big meeting about procedures. But at the absolute minimum, if you can't print the test, you could always write it, as long as the numbers correspond to what you're trying to do. So I don't want you to feel horrible anxiety about the test. I certainly don't want you to feel anxiety about how we're setting up the test. And then we're also going to have a procedure for last-minute emergencies. So if for some reason Proctorio doesn't work, we're going to have a procedure for you to sign on. Now, for a proctor to watch the exam with you, or videos, and we're going to have a whole bunch of procedures for it. And part of the reason for working this out now is to get worked out for the test. And if you have more questions about that, I'll be happy to answer them. I prefer you to ask them in in Discord, because if you ask them in Discord, one person can see everybody's answers. If you have a personalized question, you can email me. I don't know yet what SDS is doing. I don't know a bunch of these other things. I do know, if you'll notice on the time limits on the quizzes, I wanted the time limits to be 15 minutes, but then, there's an SDS concern. So I just upped the time limits to like 60 minutes. I don't know exactly how time limits are going to work. I do know we're probably going to give you more time, but all of that's being worked out this evening. This weekend's project was to make the Proctorio work and to figure out some procedures. And now we're going to have a big meeting about it this evening, where we work out more of those things. So I just want to know that I want you to know that it is going. We are thinking about it. Um, and if you have issues, by all means, send me an email, ask me on Discord. I will answer to the best of my knowledge. This is new for everybody. So, we're doing our best to make this happen. If there are any questions about that, I'm happy to answer. All right. So, yes, so the exam is going to be at the normal time. Think of this as the exam as best as possible. We're trying to simulate the environment. Okay, so you're going to sit in front of your computer. You're going to have your webcam. You're going to have it pointed at your desk area. Okay, tell your family, hey, I'm taking a test between this hour. It's going to be at 9:30, and it's going to go to its normal time. What you're going to do, what's likely going to happen is that in my class, you're going to log on to two things. You're going to log on to Proctorio, and you're going to log on to Discord at the same time. I'm going to ask everybody to get in the Discord chat. I'm not sure if that's going to work yet. But the idea is that if you have questions, there'll be a room for, hey, I've got a question. There'll be a chat channel for it. So you move yourself to that chat channel, and then a proctor or me comes and answers your question. There'll be another channel that says, I want to turn in my exam, in which case you'll queue up in that. And then I'm going to interrogate you and make sure that you filled out all the problems, and all those things. There'll also be a channel for, hey, I need to go grab some scratch paper. Hey, I need to go to the bathroom, just like normally. Well, what we're going to do is we're going to, if you get in the channel, you ask us permission, we make a little note that says you're doing this, and then we make a note in the sheet so that when Proctorio flags you, we're like, nah, you asked permission to go do it, whatever. So again, as much like the actual test as possible under these scenarios, right? We want TAs there to be able to answer questions. We're going to have emergency procedures if Proctorio fails. We're going to have this and this and this and this. And there will be a makeup version of the exam, and if you have to do a makeup. But the time is the time. So yes, so we're going to work out as much as we can all of these issues. And again, for Proctorio, I notice people have questions that ask us things in chat, and I will be happy to answer them after in text. But I want to keep going with the class. But as I said, all these what ifs about Proctorio, we are going to try to fix on this week and next week, doing the quizzes, doing the bootleg, that sort of thing. Which reminds me, the bootleg will be up. I just haven't had time to do anything else yet. And the problem set will be up. I just haven't had time to do it. I did get the WebAssign up for today. There won't be a WebAssign for tomorrow, and then there will be a WebAssign for Wednesday. So some of the stuff is up, some of the stuff isn't. There's all questions about laptops, all these things. I will be happy to answer to one-on-one. Some of those things we haven't discussed yet. So by all means, keep bringing up the questions. I don't want you to think I'm sounding void. If you've got what ifs, ask them. I'm just saying that I'm not going to address them over Twitch. I'm going to address them in the meeting this evening. Any other questions about the quiz or the test? Again, I want you to feel anxiety about the test. I don't want you to feel anxiety about Proctorio. So by the time we get to the test, hopefully Proctorio will be able to have it. All right. So let's talk about things that we wish to talk about for today. Can I go over 6 again? Yes, that's a question that's here. 6 right here says that f prime has to be less than 1/2. Well, if f prime is less than 1/2, I can't get there from here, right? If f prime is less than 1/2, I'm starting at 0, 4, and I need to get to 4, 3. If f prime is less than 1/2, I can't get there from here. Let's see. Yeah. So if f prime is less than 1/2, I could only do this as my maximum. I could only get to 2. Okay? How do we feel about that? So if f prime is less than 1/2, as far as I could get, would be here. Okay? So I can't go straight. Because I have to start at this point. I have to start here at 0. I can't start up here. If I was doing straight, now if it's double prime, I could, but this is single prime. So the slope of this line has to be less than 1/2, and I can't make it. Right? As far as I could get would be there. Okay, this right here would be the thing. And again, this problem is harder than the one on the test. And yes, if you get one of these problems, at most one thing will be wrong. Okay. Now, I didn't have to choose this condition. I could have chose this condition and not fulfill. Okay. I could have said I can't make it there, and I could have drawn my graph to be that, right? And just circled the condition that I couldn't make. So I could have done a lot of other things. Or I could have said this condition can't be met. And actually, if I said this condition can't be met and I put it up here and I said it can't be met because of this, I could actually get away with a lot more on this side, right? Because I said that was the condition that couldn't be met. And then I don't even have to deal with the kink. But that's a little too clever. And that wasn't the point of the problem. The point of the problem was to show that this is the condition that can't be met. But if you did it that way, you'd get it correct. Anyway, any other questions about this? Okay. All right, so let's talk about the class. Let's talk about today's material, because I want to do a couple of these problems. And there are excellent problems in your book. Let me just pull them up. There are excellent problems like this in your textbook. So if you go to section on the thing, if you go to section 4.2 on your book, excellent problems for this include example number 2, where you prove that x cubed plus x minus 1 has no more than one real root. And also good problems are numbers 17 through 22. These are all excellent problems. Again, 17 through 22 and example 2 in the book on section 4.2. All excellent problems. Let's do one that's similar to 4.2. Let's prove, okay, so let's prove that, let me make this smaller so everyone can see it. Okay, so example problem. Let's show that the equation x cubed plus x plus 8 has no more than one real root. Now, as an aside, how do I prove that it has at least one? This was from Module 1. As just an aside, how do I prove it has at least one? And yes, the answer is now in chat. I'd love to sing your praises over Twitch, but I don't want to say your name. Yes, the IVT. I use the intermediate value theorem to show that it has at least one. Okay? And it's continuous because it's a polynomial, et cetera, et cetera. Excellent job in chat. But I don't want to say your name over Twitch. So So I want to show that this has no more than one. Okay. So how do I do that? Well, it's actually pretty slick. And it's one of those things that's simple but not easy. But once you see it, you're like, oh my goodness, that's cool. Okay? Assume otherwise. So F has at least two roots. Call them A and B. So we're going to assume otherwise. Let's assume that there is, right? So that means that f of A equals 0 and f of B equals 0. So since f is a polynomial, it is continuous and differentiable everywhere. Everyone on board with that? And AB is somewhere. Everyone on board with that? 1 to 5. How do we feel about what I've done so far? So if I've assumed otherwise, I assume there has to be one, there has to be two, okay? And I've called these two AB, okay? Where A is the leftmost, where A is left of B. And I've said, okay, it's got to be, it's a polynomial, so it's continuous and differentiable everywhere, and AB is somewhere. So, and I have to put on the geeky gut thing because I'm having problems with writing it. Okay. So now what do I say? All right. Well, I know it's got to be differentiable. It's got to be, everywhere. It's not the intermediate value theorem I want. The intermediate value theorem would be what if I wanted to prove it had at least one. But now what I want to do is prove that it has no more than one. So I've said, well, let it have two. Then by Rolle's theorem, there exists an x value, u, so that f prime of u equals 0. Okay? I don't know what it is. I just know it has to exist. Okay. Let's take the derivative. Okay? Let's take the derivative. This piece is always greater than or equal to 0. This piece is greater than 0. I'm adding them together. All right? So f prime of u. So I've got a statement. I've got f prime of u is equal to 0, and I've got f prime of u is greater than 0. This is absurd. So I find a contradiction, right? My contradiction is that I assumed here excuse me, I've assumed here that the I've assumed here that I have two real roots. Well, if I do that, I wind up where a place where the derivative has to be zero. But the derivative is never zero. It's always positive. So by Rolle's theorem, I can have no more than one real root. Kind of slick, isn't it? Okay. All right. So that's an example of those problems. Again, there's other problems listed. Please go ahead and play with them on the thing. Let's move on with life a little bit. All right. So last time we proved Rolle's theorem, and then we used that to prove the I'm sorry. Last time we used Fermat's theorem to prove Rolle's theorem. So let's talk about the mean value theorem and its proof. And its proof is a little clever, and it's in the book. And I want to use this is one of those cases where I actually want to use the book's example. All right, so I'm going to pull out my book. I'm going to pull out my textbook, and we're going to do the proof that's in the book with the same notation, except I'm going to use U instead of C. Okay, because this is an important proof, and I want to get it, multiple places where it's exactly the same. All right, so if we pull out our textbook and we follow along, this is at the page 218. Is it 218? No, that's derivatives in the shapes of graphs. I'm sorry. I had my bookmark in the wrong place. If we pull out our thing and we go to, it's on page 212 is the proof. And what he does is something very clever. What he's doing is he's creating this new function, because the only thing that I need is the two endpoints to be different. I need the two endpoints to be the same. Here, I'm allowing the two endpoints to have different values. Okay? So I need to, in order to use Rolle's theorem to prove this, I create a new function. And that new function he calls h of x. So here's what he does. And this is very clever. And we're going to see this kind of tactic again a couple times. So let's go over it. What I'm going to do is I'm just going to create this new function. Let me give my pen a little bit more width. Okay. All right. And this new function is called h of x. So all right, so I'm going to say, okay, let f meet these conditions. All right, now define. And this kind of colon equal sign is something that's used in math to say I'm defining this. It's not, I'm making it equal by the definition of what I'm saying. Let me make me smaller. There's no need to see me as much. There's much more need to see the problem. So my ego should be diminished in the face of Koshi's ego here. Koshi's ego deserves more ego. Koshi deserves more ego space than me. Okay. Okay, well, we're about the same on ego space now. Okay, so I'm going to define this new function. I'm going to call it h of x. And again, this symbol right here means defined as. And I'm going to use it I could say h of x equals this, but I'm going to emphasize the fact that I'm creating this function. Okay? H of x, I'm going to let it equal f of x minus f of a minus f of b minus f of a all over b minus a times x minus a. Okay? So if you think about this, it's similar to, I've taken the slope of the secant line, right? I've taken the equation for the secant line, so what I've done is I've taken the equation of the secant line and I've just subtracted it. And I've created this new function, okay? So what that's going to do, so what I've done is I've got, so as a side note, this means that, let me move it up. So many mouses. So what I've done is this, okay? I've taken h of x equals f of x minus SBA of x, okay? And this right here, where SBA of x equals f of a plus MAB times x minus a, okay? And this symbol means I'm defining it as. So this is something I'm using this symbol to emphasize. Math is a bit of a language, and I could have just written equals, but what I'm doing is I'm making something stronger. I'm saying I'm creating this. This is my creation, okay? It's mine. All right, I'm defining it as. I'm the one defining it as. This was not defined somewhere else in the thing. It's me. This is my definition. This is my function. And the reason why we do that is just to emphasize the fact that I'm pulling something out of my hat. Yeah, hat, right? It's not really a rabbit. It's a magic trick, right? So I'm just defining something as something else, okay? So that's the kind of thing. But what I'm going to wind up with when I do this is I'm going to wind up with something that I can use Rolle's theorem on. And that's the whole point, is that Rolle's theorem can be applied to H, okay? Well, Rolle's theorem here is an algebraic combination of something continuous, okay? So I need to say that, right? H is continuous on AB because F is continuous. Okay, and this is just an algebraic, right? This is a constant, this is a constant, that's a constant, that's a constant. This thing right here, so here I've got the function f that's continuous, okay? I've got constant, this is a number, constant, 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 times x minus a. And this right here is just a line, okay? So what I have is a continuous function minus a line. Okay, so how do we feel about that 1 to 5? That idea here that what I've got is continuous. Okay. All right. I've got some non-voters. I imagine what I've got is some people that have jumped out of the stream because I'm bored. Which is, there's a reason I'm recording it. You can see the recordings. There was also a mention, so I don't know if you know this, but the videos show up in two places. They show up on Twitch on the video thing, but they also show up on YouTube later in the afternoon. So you can get them in two places. And the nice thing about YouTube is that YouTube closed captions them. So if you're in a busy place and you can't, um, you can't hear everything I'm saying, then you can watch them on YouTube, and YouTube closed captions things. And if the closed captioning's off, you can hit me a thing, and that's a thought. Maybe I can do the extra point by making you closed caption one of my lectures. I'm just kidding. I wouldn't do that. I am thinking about something for the extra point though, but it won't be that. That's just me. That's like, I'm going to give you an extra point if you do all this work. Kind of like independent studies, right? You're going to pay me, the professor, to go do work for me. Only in the university can they pull that off. The chemistry department, by the way, does a great one. You have to pay to be a peer leader. We actually pay our peer leaders, but chemistry has got a good racket going. Anyway, they give you a credit. All right. Likewise, F is differentiable over AB, same argument. I took a differential equation, I subtracted a line, I get something differentiable. Okay, that means there by Rolle's theorem. Oh, and I need to show that H of A, I'm sorry, and this should be H, not F. Same argument. Okay, now I need to show that H of A equals H of B. Okay, so, all right, so H of A equals F of A minus F of A minus MAB times A minus A, which equals 0. H of B equals F of B minus F of A minus F of B minus F of A over B minus A times B minus A equals F of B minus F of A minus F of B minus F of A equals F of B minus F of A minus F of B plus F of A. Okay, so all the details are worked out. Okay, how do we feel about that, 1 to 5? Yeah. So this bit here was H is continuous and differentiable where needed. Okay. So I've met the conditions for Rolle's theorem. And then, so h, there exists some u in there so that h prime of u equals 0. All right. Everyone on board with that? Okay. Now, because I meet Rolle's theorem, that's going to mean the following. That means that, let's figure out what h prime of u is. H prime of u equals, well, this was what f of u was here. This is what, oops, wrong one. This is what f of u, this is what h of u equaled. So let's take the derivative of that. Well, that means that h prime of u equals f prime of x, right? Just do the sum rule. Minus, okay, this bit's 0. Now, this is going to, this right here, this bit here, oops, wrong one. This bit here is multiplied by x minus a, okay? So this is just a constant that hangs out for a moment. And then the derivative of the inside, the derivative of x minus a. Okay, so let's do this. Let's do this a little bit more formally. Let's say, okay, h prime of h u equals d over dx of f of x minus f of a minus, I'm going to write this as mab because it's just a constant, times x minus a. Okay? Now, let's look at my pieces. Okay? Let's work out this bit so it goes away. And I'm going to have d over dx of f of x minus f of a minus mab x, should be a times x, plus, what I'm doing is I'm multiplying this out so I don't have to deal with the product rule. Plus mab times a, okay? And now what I have is something I could just apply the sum rule, and I get the following. I get f prime of x minus 0 minus mab times 1 plus 0, which equals f prime of x minus mab. And all of these things should be a u, by the way. I'm sorry. Okay. All right. And we knew to use rolls. We knew to use rolls basically every time we meet the conditions for rolls. Okay. You know, what are we trying to do? We're trying to show that somewhere the derivative is 0. Well, remember that all of this, h prime of u equals 0. So 0 equals f prime of u minus mab, which implies that f prime of u equaled mab, which is what we wanted to show. Would it be? Yes, it would. Would it be? No, I'm actually talking, well, yes, I am. It actually wouldn't be. It'd be d over dx evaluated at x equals u. Uh, you're right. I screwed it up. These should all be x's. These should be x's if I'm being nice about the notation. Don't I feel like an idiot? This should be an x. That should be still a plus. But these, okay, so this line should all be x's because I'm evaluating at u. But then this should be f prime of u, and that should be f prime of u because I'm talking about a specific spot. How did he do it in the book? He used a C, and he didn't do the whole, he didn't actually explain this bit. He just assumed that was obvious, which is nice of him. Okay, so he didn't actually do, so in the book, he didn't do these two steps. I did them. You don't have to do them on your proof, but you have to know they exist, so I'm being detailed oriented. But I did screw up the notation, and you are right. But it doesn't change the d over du, because the thing that's actually moving is x. And what this is d over dx evaluated at a specific point, x equals u. So these should all be x's on this row, but then when I move to prime notation, this should be a u. My bad. Okay. And that's super confusing, and I wish I hadn't done that notation. But I did, so. Which means for the next class, I won't make that mistake. So don't get lost in the notation. Which is what I wanted to show. All right. So besides the notation, which I really don't want you to get lost in, how do you feel about that 1 to 5? Okay. All right. Okay. So there's one more major proof in this section. Okay, and I'm going to do mine a little bit differently. We're going to use this idea. This idea of creating a new function is very important to us. And we're going to use it one more time. And we're going to use it to prove something that's very important. And let me see which page he proves it on. I mean, there are a bunch of other things that you could prove this. And indeed, L'Hopital's rule, which I should tack on to the end of this, I'll probably do it at the beginning of the next lecture, is a consequence of the mean value theorem as well. We did it as a consequence of the ratio of linearization, but if you want to do the full proof, which is in the appendix, which I am not going to do, you need the mean value theorem to do it. Okay. So what we want to prove is, he calls it corollary 7 on page 215. We're actually going to do it as one big proof. Okay? So what the last thing we want to use, and again, the mean value theorem is like a big, bludgeon. It's used to prove a lot of stuff. And I know that I've done now 2 lectures with very few problems. I've only done 1 problem from this whole section, and I've done nothing but major proofs. Because all the major proofs in calculus depend on this. Indeed, the fundamental theorem of calculus, it depends on this. It depends on this one bit. So this proof right here that we're going to do next is extremely important because we use it to prove the fundamental theorem of calculus. All right. So we need this fact. And this fact is the following. If g prime of x equals f prime of x for all x in some interval d. So let's do some preamble here so we know what we're talking about. Technically, it should be an open interval, but I don't actually care because, you can get around the thing. Let D be an interval. Okay. Now, if g prime of x equals f prime of x for every x in D, then there exists a constant C so that for all x in D, g of x equals f of x plus c. Okay? In other words, if I have two functions and their derivatives are identical, they differ by a constant. Exactly. Okay? In other words, this is a statement for the theorem. Okay? And I don't, it doesn't have a name. It probably does, but I don't know it. Functions with the same derivative. Okay? How do we feel about this statement? Just what the statement is. I'm not proving anything yet. I'm just asking for the statement. How do we feel about the statement of this thing? Yes, can I draw a picture about that? Okay, so for example, x cubed minus x squared. Let's do 5. Let's do 6. Let's do some major. And x cubed minus 6x squared plus 5. Okay. Now, this is not the proof. This is just a picture of what's happening. Okay? If two functions are vertical shifts of each other, you already know that their derivatives are going to be the same. This says that's the only way that can happen. Okay? This theorem is saying that if two functions have the same derivative, okay, two functions are vertical shifts of each other if and only if they have the same derivative. And you already know that if I add a constant, I'm not changing the derivative. This is saying that's the only thing that you can do and not change the derivative. Okay? How do you feel about that? Right? So one direction is obvious, right? Because the constant goes poof, they result in the same derivative. Okay? But this is saying something that's stronger. This is saying that's the only way to get two functions with the same derivative. Okay? The only way to get two functions with the same derivative is a vertical shift. There's no other way to do it. And that's much stronger. Okay? This is this is that if and only if part. Okay? And we need the mean value theorem to prove this. And it's an extremely important fact. Okay? And how much time do I have to prove it? 5 minutes. Okay, I don't know if I can get it done in 5 minutes. So I may go over, and I'm sorry. Okay, so let's just prove it. And again, the book does a similar proof. But how can we get at this? Anyone have any thoughts? And it involves the mean value theorem. Let's assume otherwise. I will talk about sine and cosine in a minute. And it's not so much sine, it's inverse of sine that has the same derivative. And there's a really cool thing that goes on there. Let's assume otherwise. Now, what would it mean to assume otherwise? Okay? That means, all right, is everyone on board with that statement? What I've done is I've assumed that they're not equal to the same constant, right? I've assumed that f of a minus g of a does not equal f of b minus g of b. In other words, if this equaled c, okay, I've assumed that if I've assumed that these two things are not equal, okay? And what I want to show is that leads me to a contradiction. How do we feel about that? 1 to 5. I've said that they aren't vertical shifts of each other. In other words, I've said that the change from one to the other has to be different. Okay. All right. So we're kind of okay with that. Okay. Let's divide both sides by a minus b. I'm sorry. This should be f of a minus g of a. Yes. Okay. This is true if a doesn't equal b. Now, that's the point. What I've said is that for every x, right? My assumption is that I'm sorry. The thing I'm trying to prove is that for every x, those two things are equal. Okay. Okay. So what I'm trying to show for all x, g of x equals f of x plus c. In other words, for all a and b in D, it is the case that f of a minus g of a equals f of b minus g of b. All right. I've said that that's true. That's a horrible minus. Okay. I've said that for every x. Well, these are perfectly good x's. A and b's are perfectly good x's. So if this is true, if it's the case that g of x equals f of x plus some c, that means that for any a and for any b, f of a minus g of a equals f of b minus g of b. Okay? That's what it means, right? I'm differing by at most a constant. That means that the differences at every A and every B must be equal. In other words, what I'm saying is this. I'm out of time, and I'm sorry for going over. What I am saying is this. I'm saying that the difference between these two functions is constant. Okay? All right. Okay. So now what I'm going to do is I'm going to subtract these things, and I'm going to divide through by b minus a. Because b does not equal a, I can divide through by b minus a. But what I'm going to do first is I'm going to rearrange the terms. Okay? So I'm going to wind up with the following. I'm going to put everything on this side not equal to 0, and then I'm going to divide through by a minus b. Or I could just leave it like it is here. But I'm going to move f of b over to this side and f of a. So f of b, f of a minus f of b does not equal g of a minus g of b. Okay? And then what I'm going to do is I'm going to divide through by b. Because what do I really want? I want to use the mean value theorem on this thing, right? Okay. How do we feel about what I just did? 1 to 5. Okay. All right. Okay. So consider the following function. All right. Everyone's on board with this. Okay. You know what? Let's make this a little bit easier. Let's make this easier on our lives. Okay. Okay. Now, how do we feel about that? I'm saying that the difference is not equal to a constant. All right. Now, okay. Is everyone on board with that last statement? 1 to 5. How do we feel about that? All right. Okay. I'm like way over our time, I'm sorry. From our assumption that f of x equals g of x everywhere, okay? So, now, I notice h of x oops, sorry, bad symbol. I'm in a hurry, so now, what is h of a minus h of b? Okay? Over a minus b. Let's go back up to here to this statement here. Okay? Here I've got f of a minus f of b minus g of a minus g of b all over a minus b does not equal 0. Okay? Now, h of a, right? What was h? H was f minus g, right? So this right here is f of a minus g of a plus, minus the quantity f of b minus g of b over a minus b, which equals the quantity f of a minus f of b minus g of a plus g of b here. Right? I've got a minus and a minus here. I got a plus, right? Now what I'm going to do is I'm gonna deal with this term here. This term right here, if I split it up, equals f of a minus f of b all over a minus b plus negative g of a plus g of b all over a minus b. And this term here, when I take out the negative, I got to make that term a negative. So this term here, when I take out this negative to make it all negative, I'm going to have to take out a negative. This is going to become negative. So that equals f of a minus f of b all over a minus b minus g of a minus g of b all over a minus b. Right? And that equals h prime of u, which equals 0. And now I have a contradiction. So what did I do? I threw a bunch of spaghetti on the wall and found out what stuck. That's basically the answer. How do we feel about that 1 to 5? I know I'm way over, and that like half of you have like left, and half of the people in this chat that are watching the stream are from the next class. But how do we feel about that 1 to 5? Okay, so that's it for today. I'm going to run up real fast. Did I put on the outline what was next time? Yes, I did. So next time we're going to start with optimization. I will move the thing back. Next time we're going to start with optimization. And I will post nines. So does h prime of u not equal 0? Yes. Because remember, I said that up here. I said that f prime, this is the thing I'm contradicting. Right? So this right here, okay? That's the thing that I'm contradicting right up there. Okay? The thing I will contradict was that these two things can't be equal to each other. In other words, subtracting them can't be 0. And then I've shown that, however, I've shown that they have to be 0 someplace. Okay, I've shown that h prime of u has to be 0, and h prime of u needs to equal these things, right? So I've got two things. I've got something that does not equal 0, and I've got something that does equal 0. And that's the contradiction. Okay. Some people are uncomfortable with this proof. I'll talk about it some more then probably in Wednesday night's thing. You can also watch the video for the next one, which I promise I'll probably nail this proof a lot more sharply. Any other questions? Okay, I'm going to log off Twitch now. I'll answer any questions in chat, but then I have to set up for the next class very quickly because I went over. Horrible person me. I went over. I'm sorry about that.